Thank you so much, SignalFire team, for hosting us. Just like what Josh said, they have a very strong focus on community, and so we actually got to meet 2 years ago with SignalFire team over Zoom. This is actually the first time we're seeing each other in person, so this is amazing. I was just talking to Owana about this. Now, my name is Richard, and I'm the founder of Iterative Ventures. It grew from a syndicate, and now we're evolving into a fund, and my focus is in Web3 infrastructure, which is why I'm so excited to talk to Matthew. Beyond the fact that we used to, or he's a much better dev than I ever was, so which is why I turned the other way. But after reading his white paper, etc., I can see that what Matthew's solution is going to be solving for a lot of problems. So, just to get a show of hand, how many people have traded NFTs before? Okay, how many people don't like the lack of predictability for your gas fees? You're laughing. Great. How many people don't like to be front run? Of course, everyone. Okay, great. Well, here's where Matthew comes in with his great design, and Matthew, please take it away with your mission objectives.
Okay. Well, and first, thanks so much, SignalFire, for hosting us. This is such a great space. Really love it. Thanks, Richard, for the introduction, organizing also the event. So somebody was laughing. I think he saw it coming through the question. So Linera. So first, it's based on so we really believe in Web3. We really believe that the blockchain has the potential to change how we organize human activities, like to create really just like this incredible organization on the internet that is going to create value for people, and especially so allow the internet to transfer value, to deal with what was missing basically, and in the previous revolutions of internet. So, but of course, to do that, to deliver, blockchain needs to be reliable, and so reliability means that it needs to be just working. So that's the experience people have been having with the normal internet. You use let's say you use Google Maps, and you're in a traffic jam. Lots of people are using Google Maps next to you, but it still works. You still have like a good experience of the product, and you don't need to think about do they have enough servers to back your queries in your car, right? So it just works. That's how tech's supposed to work. It's supposed to be kind of magical, and you don't have to know about the details. And now there's a secret sauce to it. So internet was not always like this. There was a time where occasionally you see a government website that just crashes. There's too many people in it. And the difference is that people invented elasticity. So people came up with this notion that with planned infrastructure, you can design a system, a classical internet system, so that you can always add workload and to be able to take the user queries and just provide them with this uniform experience across time. And so that's what we're doing. We're doing that for the blockchain.
So, with what you just said, obviously you've did a lot of research. You were a research engineer at Meta. What were some of the things that you uncovered that motivated you to go this direction and have this kind of design?
Yeah. So I was several years just a software infrastructure engineer at Facebook, and then I was lucky to be one of the first engineers at the blockchain project, so called Libra, and then Diem. And I think from the back of my mind, I could not really shake the idea that we had a scalability problem. So we were doing things like everybody else, but like if you talk to an engineer in a big tech company, and if you build a service at Facebook, Google, or in big tech company, and it's not linearly scalable, your colleagues are going to tell you please don't, because we're going to have to do it again in 6 months, right? So there is a gap, and I was kind of with some of my colleagues, we were kind of obsessed with this gap. We're like, okay, we're building a blockchain, but it's not going to be scalable. It feels bad. And so when I had the opportunity to become a researcher in this organization, with some colleagues, we had this idea of a payment system, and we kind of re-engineered the thing to use a different kind of consensus protocol that was, and at the time, so we came up with this payment protocol called FastPay that was linearly scalable, and so we're pretty happy. It was a nice paper, nice academic research, but it was only payments. So that was 3 years ago, and yeah, so we got our publication, and we're like, okay, that's cool. We don't know how to make a blockchain infrastructure out of it. It's just payments. So it stayed there for a while, and in 2021, I started working again on this thing, and I started finding generalizations. And suddenly, for instance, I had an idea to do atomic swaps in a linearly scalable way. And that's where I was introduced to investors. So that's kind of like the story of, yeah.
So obviously you have a lot of other colleagues, right? Such as the guys from Aptos and Sui coming out, and they have various design trade-offs and whatnot in their system. I'm curious, one of the key factor differentiator of your chain versus theirs is that you're using Rust. And why is it that you're using that as opposed to Move?
Okay. Okay, it's not the main differentiator. I mean, so one thing is that I was in a startup before doing a web programming language, and at the time, I decided I would never do it again. So that's one reason why I prefer to just use a language that is already widely adopted. And then taking it from there, so we want to be language agnostic, so we may support Solidity later, perhaps Move in the end, who knows.
Thank you, Matthew. And so you said that was not your main point. So your main point, from your paper that I read over and over, is that you're looking for, or you're trying to design for predictable performance, security, and responsiveness at internet scale, right?
Yes.
Could you elaborate a little bit more about that?
Yeah, thanks. So Aptos is based on the, okay, now we're going into the details. Okay. So Aptos is based on the code base of Diem, which are very much inspired by classic blockchains like Ethereum, Solana. And so it's one main blockchain, and then they optimize the transactions per second. They optimize the throughput so that it apparently reaches something like 100,000 transactions per second. They have this idea of called block STM. So the idea is you kind of try to detect what transactions are independent so that you can run them concurrently on different machines. So that's what they're doing. I think in Linera we're looking at something like entirely different, where we don't want to the high TPS. So we want high TPS, okay, but it's not going to come from a single chain that is like super optimized. It's going to come from just a multitude of small chains, and we want to be able to add those small chains and have many of them in the same set of validators. So have a homogeneous system with lots of, we call them micro chains. And so the TPS is going to come from this multiplication of low TPS chains, not from a high TPS chain.
Okay, very good. And another differentiator of your layer 1 is that you enable auditing at scale by the community. Now, can you elaborate as to why it's important to audit?
Yeah.
And why is it important to audit at scale by the community?
Yeah. So in fact, because it's been a criticism for precisely high TPS systems. So everybody wants a high TPS blockchain infrastructure. Now the question is like, is it still decentralized at the end of the day? When you look at the designs, it can be really hard for the community to kind of understand what's going on in the system, because precisely it's high TPS. So if the validators are like this massive set of machines, like perhaps like really beefy machines, then it means that with a lot of network connectivity, if you are outside of if you're not one of the validators and you want to execute the transactions to verify what's going on, it's pretty hard. You need to basically have the same hardware, and so people have been worried about centralization in that kind of scenarios. So the nice thing about the approach in Linera is that we prefer to have many small chains. And now what's going on is like from the outside, you can choose a chunk of those micro chains and you can just audit them on just commodity hardware. And then someone else can audit another chunk. And so collectively, the world can just, using commodity hardware, can try to figure out, try to audit the system and figure out that everything is playing according to the rules. So that's going to be a big difference. So yeah, we prefer to have lots of low TPS chains also for that reason, because you can audit the system much better.
Can you elaborate a little bit about why auditing is important for blockchain specifically?
Auditing?
Yeah.
Okay. Yeah. Well, I mean, it's kind of what I was saying. So you trust the validators, but you also want to verify. Is it trust but verify? Okay. So you want also to discourage them from deviating from the protocol and trying to hide the system, right? So what you'd like is to have in place all the auditing framework so that if some validator start deviating, maybe double sign some packets, so some blocks, then you would find that and you would slash them, right? That's standard in proof of stake, but it's kind of hard to do in a high TPS system usually. Yeah.
That makes sense. And can you elaborate a little bit as to why you've chosen to design with elastic validator sets as opposed to other types of approach?
Yeah. Okay. Yeah, so something I haven't said, so in the description of Linera, so if I summarize, so we want high TPS, we're going to use lots of small chains, and they're going to be in the same set of validators, okay, and so one validator is going to handle all the chains. So that's pretty original. Usually people want to have more like small validators. And that's where we changing the formulation of the problem to solve the blockchain trilemma. We're saying we're going to have maybe fewer validators than usual, but so first we're going to audit them a lot from outside, like I explained, and then each validator is going to have all the chains and is going to be able to be elastic. So when you have so all those chains, they run in parallel. Okay, and so now if you're a validator and you see that some of the chains are like super hot, you can put them in different shards internally to your system. So the originality here is that the validator in Linera is going to look like a traditional internet system with a load balancer, a bunch of workers, maybe a distributed database. So we're applying the best practices in the world of Web 2 to each validator, to make them scale elastically. So that's kind of the originality of the system. And so the shard, if you compare that to blockchain sharding in general, this is entirely different because we have only one set of validators for all the chains, right? In traditional blockchain sharding, you have different chains and each of them has a different set of validators. So in the classic configuration, the problem is it's hard to have many chains because you need to find the validators. Each of them has a different set, and then it can create a security trade-off. As an attacker, you got all those sets of validators, and you could try to find which one is the weakest, for instance. And then the third problem with the traditional blockchain sharding is that the chains you want them to communicate, otherwise it's kind of useless. So how do you make cross-chain communication efficient? It's kind of a difficult problem in traditional systems. So in Linera, since everybody is in the same set of validators, you can have efficient cross-chain communication using the internal network of each validator. So that's kind of the summary, technical summary of the system.
Thank you so much, Matthew. And as I was alluding to in the beginning of this conversation, part of the problem is also that you might be front run, etc. I'd like to touch a little bit upon that in your design as well, right? In the sense that because your blockchain, in traditional blockchains I've seen in other white papers. They're all mostly designed with mempools, etc. But your blockchain design is quite different. It gets rid of mempool, it seems. Correct me if I'm wrong.
Yeah. So yeah. Thanks. So once you decide you want many chains because that helps with scaling, and you're going to run them in the same set of validators because that helps with cross-chain communication, there's one problem left. It's like how do you get all those chains? Like who's going to create them? And also, is it going to kill the operational cost of the system? So this is where we came up with the idea that, and that's rooted in the research I was mentioning from 3 years ago. We came up with the idea that we want to encourage our users to manage their own chain. So we're going to tell them, hey, please create your own chain, and you're going to have a simplified protocol for you. So when you're talking to your own chain, you can create a block in a very simple way. Basically, you just tell the validators, this is my next block. They validate it. They send you back some signatures. Once you get a quorum of signatures, you have already a proof of finality for your own chain. So there's this very, very simple protocol that we can use for a chain as long as it's owned by a single person. So that concept of a chain owned by a single person, I think, is completely new. It's really coming out of the research we're doing, and it's really what's enabling the system, like allowing the system to have so many chains, right? Also, the idea is that if a user is not really creating blocks, then the chain is just sitting there in storage, and it's not costing anything to the validators. Because so if we want millions of chains, and we have to continuously, gossip empty blocks, as would be the case for traditional consensus protocols, then the system would just go to a crawl, right? And so one of the ingredients of the system is also this optimized consensus protocol, based on reliable broadcast, actually. So with just a few round trips to create a block.
Thank you, Matthew.
Oh, and you were asking about MEV. So now, I didn't forget. So when you are talking to your own chain, you're just telling the validators directly, this is my next block. So there's no mempool. So there is no front running. So that's another benefit of the solution.
Right, because then miners can basically go in and reorder the transactions, et cetera, to extract those values, right, et cetera.
In different systems, with the mempool, yes.
Makes sense. Zooming out a little bit, obviously what you've talked about a lot is about how to scale a blockchain, et cetera, hence the Linera design. Now, I've been hearing stuff about, for example, rollups. For example, optimistic rollup has been all over the hype, and people have been saying that ZK is also the next leg up for this year. What's your take on that? Okay, layer 2. So yeah, it's raging right now. I'm super interested in the tech. And for me as a layer 1 person, I'm interested in, that would be chain compression, would be the way I would apply the snarks. So to facilitate decentralization and avoid also recomputing things in parallel everywhere. Once you have a proof of execution, then you just need to verify the proof. So that's super interesting. So that's my take on layer 2. I think it's especially the ZK rollups. I think the tech is awesome, and I think we could use it in the future. Now, now once you have the tech, you can decide, do you want to use it in the layer 2 because you think that the security of the original layer 1 is the one that is the kind of security you want to tie yourself with, or do you think that you prefer to have an independent layer 1 with experimenting with new ideas? In the case of Linera, so like more scalable, for instance. Would rollups potentially compromise on security? As I've seen that's written in your paper, so I'm just curious as to whether, what your thoughts around that, et cetera. Whether there's any trade-off in using rollup. Okay. So the trade-off with the rollups is that as long as your transaction is not confirmed in layer 1, it could, theoretically speaking, it could still be cancelled, right? So you're trusting the layer 2 to, when the layer 2 tells you, okay, your transaction is in, it's gonna happen,
until it happens, you just have the word of the layer 2 for it, right? So that's the trade-off. It's more trade-off for in terms of liveness and fairness. So not so much. So safety is cool because at the end of the day, it's supposed to be confirmed, and then you can see you have the proof, the proof on that is validated on the layer 1. But the trade-off is more in terms of fairness, which is a form of, or to say it differently, MEV, right? So you're trusting the layer 2 to put together this very, very large block of transactions. Now they can try to reorder the transactions to optimize their value. So that would be a concern. So now we're also seeing that some of the layer 2s they're considering using some form of decentralization. So having also a little bit of replication. So when that happens, they're going to start looking a little bit like Linera. so that's why I think it could be converging.
Very good. Can you also elaborate a little bit, before we go to Q&A, can you elaborate a little bit about your roadmap and some of the ways that we could work with Linera?
Yeah, so our roadmap, so we're working on the software development kit right now, and we hope to put it out there, open source everything in a couple of months. And then it's going to be it's going to be super interesting to see to get feedback from developers and see what they want to build. And after that, we go DevNet, testnet, and then sometime later mainnet.
Do you have a rough timeline on that?
I think we want definitely so I told about the software development kit. The DevNet is going to follow, and testnet hopefully this year.
Thank you, Matthew. Want to open up Q&A for the audience.
All right.
Quick question.
And can we stand also, because I think
so, Cisco Regional Ops guy, how fast do you think you can update sharding in the micro-transaction model or the micro-validator model? Is it sub-second? Are you looking at real web performance, or is it like most of the other chains that are in tens of seconds, like Ethereum tried to sell us when they did the merge? What do you see as a performance level for your reasonable performance level?
Yeah, thanks. So what we like with this notion of micro-chain, so if you are talking to your own chain, there is this super simplified protocol that potentially has really the minimum number of round trips you can imagine. So like 1.5.
1 and 2 hops, yeah.
So and now, so if you do so you have your block proposal and you're talking to all the validators in parallel directly, because that's also kind of the system, what we want in the system. So if they depends where they are, where you are, it could be 200 milliseconds time 1.5.
Oh, 20, that's pretty good.
200 milliseconds. I mean, if you got the normal internet latency, right? Yeah. That's kind of what we're talking about.
240 milliseconds on top of that. Yeah,
right.
Locally and regionally, but 2 seconds.
So this is where it gets interesting, because now what's amazing about sharding is that you could also imagine a future where each validator is geographically sharded. So
like the guys at HoloChain are doing.
So a validator could be in fact a collection of data centers with a backbone in the middle, and if you have a presence, if all the validators have a presence in Manhattan, just saying, and now you want to create a block, your chain is handled in the shard of Manhattan.
Yeah,
then you don't pay the cross continental latency anymore.
Well, it may not be expensive. Like that's one thing HoloChain is doing. It's important. Like we do with subnetting for routing, you look for closest hops. So if you do I don't know where you're at on it, but HoloChain's doing a thing where they read the actual number for closest, because they let you put up to 50. How would I say this? Peers. And you can choose based on the numbering system, the routing number system, how close they are. Are you giving them a preference in the actual block? Is it biased towards closest hops? Are you doing any testing of what the performance of closest validator is? Any of that stuff, or some people need to write on it?
Well, I mean, so this geographic sharding is, you have to imagine that the system is like so immensely successful that suddenly validators, they have a business model to have data centers in different parts of the world, and then you get this low, super low latency.
No, they're open source routing protocols you probably can grab and can offline that.
Right.
That already do that, so like they can look for that. So that would save you time and performance. But you'll offline that. That's a little
Okay. So you're saying that using a different communication system
yeah,
to
open
talk to
source
the
stuff that does most of the routing in the world, like Erlang and BGP
Okay,
and stuff.
okay.
Yeah. Sorry, yeah.
All right.
Yeah. But I will offline that.
Okay. Yeah. Sure. Thanks.
What's the reward for being a validator? What's the incentive?
Yeah, it's going to look very much like any other system there. So it's going to look like normal system where you have a yield. It's delegated proof of stake. So we're pretty conservative. We're pretty crazy on some of the parts of the design, but this part is very, very conservative. The delegated proof of stake and the yield is going to be like everybody else.
So you have a token for the system?
Yeah, it's going to be a token. Yes.
Any idea on the tokenomics?
Well, we have lots of time to figure this out. Yeah. So, but it's going to be very classical, like state of the art. We one of the things we're going to be very careful about, of course, is the concentration of stakes. Try to make sure that validators, they want to stay like the nominal size.
One more question. In a system that needs to be audited, is there going to be transaction limitations?
Transaction limits in what, sorry?
In a system that needs to be audited, is there going to be transaction limitations? Like Lightning Network has a cap on the transaction.
So what you could do is you could say a microchain maybe cannot grow too much, and after a while you need to create a new one. So that's something you could do to make auditing easier. So you could say like, yeah, we prefer microchains to be relatively lightweight. So if you start putting a lot of transactions, after a while we tell you, okay, can you close that one and create a new one to facilitate the work of validators. We talking about tokenomics, something we want to figure out is how to reward auditors. Because so validator now the requirements for our validators are going to be relatively high, but we want the community to also participate in the system and as auditors in this case, and get rewarded for it.
What's your opinions on moves and language itself?
Yeah, okay, so I worked on the move prover briefly myself. I mean, I was helping the team with the SMT solver, if you want to know. I think it's great. If you want to do formal methods in particular, I think it's one of the best solutions. If you want to do formal proofs of smart contracts, they have a framework, like I said, the move prover. So the language is very principled, very clean, and it's going to help you do the proofs. Now, I'm not sure that's what people are actually asking for in the current market, that people are doing formal proofs of smart contracts. So personally, basically we showed, this is what I was saying, we decided to be language agnostic, so we start with a generic language like Rust, and then we're going to add more languages, more specialized languages later. So perhaps Solidity, perhaps Move, we'll see. But we're starting with Rust.
You started by mentioning NFTs and gas prices. Is there a particular sector or segment that you want to focus? NFTs, DeFi? Is there any in particular that you want to start?
Yeah, all of the above. No, we'll see. We'll see. It's going to depend a little bit on the partners we can find, and I think the strength of the protocol is for everything low latency and highly scalable. So NFTs, it would make sense for NFT airdrops, for instance. We could do that because the system would be able to absorb the workload. DeFi is super interesting. This was my initial motivation to start the project when I found out to do atomic swaps at scale. I'm still ready into it. It may take time. We will see the market conditions. You know, like right now, it's not like ideal. And there is a lot of what's interesting with DeFi is that we would in fact to take advantage of Linera, we would have to reinvent many of the protocols to make them multi-chain so that they can really scale horizontally. Right now, DeFi is a single chain. AMMs, flash loans. So this is great, but it's very different from what we're having. So, but I think eventually, yes, we definitely want to have like our own versions of the and super scalable version of DeFi protocols.
So could I offer an option that we told the guys if Ethereum merge, just still the open source shit we use that routes the rest of the world. It's almost like airline protocols. The stuff we use for BGP that's open source, it works in every browser, a lot of the chains. Just steal it. We built it open source, we made every company and country in the world use it.
Okay.
And you can steal it, just use it. Don't
Okay,
tolerate
tell
it.
me more about that later. Yeah, sure.
Yeah.
Of course. Yeah.
I was wondering if you could expand on your answer to NEV earlier. I was having trouble following exactly what you meant about, in your example you had sort of a personal chain, someone proposes the next block within a personal
Right.
chain. The concept of ownership that you were implying there, and then it's submitted to a validator that cannot mess with the proposed block. I
Okay.
think was sort of the implication.
Yeah,
I'm
so
wondering how that's possible, as opposed to them being able to redefine that block and then to become a member of your chain and sort of participate in a somewhat disruptive fashion.
okay, yeah. I mean, to reason about MEVs, we would have to look at a particular application. So like a decentralized exchange built on Linera and see where the front-running opportunities, where they are left in the system. The example I was giving was like for just a simple payment. So I was just observing. So when you create a block in your own chain, in this framework of microchains in Linera, basically the validators, they learn your intention when you are already doing it. So you broadcast the block you want to create, you send it to all the validators in parallel, and by the time, so they sign it, and basically it's already final then, and basically it's already happening when the validators learn what you want to do. So there's no opportunity for somebody to observe, especially if they are not validators, by the way. So first, there's no public mempool that you can just observe. But even if you are a validator and colluding with someone else, you are observing that, okay, he's creating a block and that's it, the block is created. So there's no, you cannot, I mean, in this particular chain owned by the person, you don't have really anything to inject. So now, if you want to look at a place where they could have more influence to reorder, so that would be the reordering of messages, for instance. So when perhaps your chain, what you're doing is you're sending a message to another multi-user chain that is in charge of perhaps a decentralized exchange or something like that. So in that framework, the nice thing we have going for us is that we could timestamp the message and put some constraint on the ordering in this pool, in this public chain that has the exchange. So this is obviously work in progress, but I think I may make the argument that we have more tools at our disposals because we can have these trusted timestamps on the messages in the system, because people are going to first create a block in their micro chain, and then a message is going to be sent to whatever market maker is in the system. If that makes sense.
Maybe, I guess the question was, if there's enough value to extract in what is being proposed, then what is preventing or disincentivizing validators from colluding to say, well, we all just saw the block, to your point, we just saw it. However, they still are the ones deciding whether it's making the chain, the other one's validating. So why can't they all just rewrite the block?
Rewrite the block?
Yeah.
No, they can't rewrite the block. No, I mean, if you are talking about a chain owned by a single user, so that's the only person. This user is the only person that can create block.
So there's a concept of ownership then.
Right. So so there are several types of microchains. The one that is very unique is the one that is owned by a single person. So as a user, you would act as a leader of that chain. Just pick the blocks that you want in sequence. And so that's where there's no Mempoool, for instance, right? No way to insert anything in your chain. So the validators, the only thing you can do is try to censor you, but you would need a very large amount of validators to collude to do that, right?
How many? For like
you need more than a third.
One or two market.
So it's a quorum system based on BFT security. So you need to create a certificate, you need 2/3 of the votes, or to say it differently, to stop the system, you need 1/3 of the votes. That's right.
So 1/3, so say it's 2 people chain, 1/3 of that is like 2 people.
Now we want a substantial number of validators so that 1/3 is still big.
I do have a follow-up questions on the validator. So what stopped the validator from colliding with the owner?
With the owner?
Yeah.
Oh, they can have their own chains. Yeah, that's
They
fine.
they collude, corrupt together. Like what stopped the validator to collude or corrupt with the owner, creating some fake chain?
Oh,
Or just rewrite the history of the record? Not rewrite, but say they added
so
the history of the block.
the validators, they can have chains. That's fine. They can have their own chains, right? But if you the security of the system relies on 2/3 of the validators to sign everything, right?
So what can I say?
2/3.
It's multi-sig, yes. Yeah. It's a standard notion of quorum. Yeah. So if you don't have, yeah. So as long as you got 2/3 of the validators that are honest, you have the proof that every single chain is consistent across the entire system and follows the rule of the execution. It's a standard. So the nice thing about using the concept of blockchain is basically you have the same security level as usual, right, for each of the chains. So and since we use a single set of validators, basically the whole thing has the same level of security as traditional blockchains.
How many percentage of the people on the chain do you think will be validators? And what's the size you're starting with at launch? You want to reach, what's your goal?
So the number of validators, that's an interesting question. So if we want to tackle low latency use cases, the ideal number of validators would be a number that you can still talk to in parallel, right? So, and you have to also realize that, so for a high TPS system, if you have like 1,000 validators, the operational costs are multiplied by 1,000. So you want to be reasonable there instead of, in terms of number of validators in a high TPS system.
I mean,
So we'll
it's
see.
a value transaction or chain, it doesn't matter, and they'll be incentivized to get fast machines to do that, because they get rewards for taking,
You
serving in validation.
You could imagine a system where fast validators are in fact, yes, indeed incentivized.
Yeah, like if they're finding opportunities where to put cash in on flash trading with flash loans, it makes sense, just like you do with people who come up with, what do you call it, quants. I find a commodity or something that should be bought into, and cash goes to that, and they can validate that's a legit opportunity. Cash will go to them in a flash loan, they'll execute fast, and they'll pull the cash out to everybody else. Yeah, that's it.
So
Especially in DeFi.
yeah, so we'll see the optimal number of validators. But for me, if I have to give a number, I would say maybe 50, 100. That's my guess. We also want to be client friendly, so that the users, if they have their own chain, they are going to have their small full node for their small chain, right? And when they talk to validators, they're going to have to do n parallel queries, right?
Mm-hmm.
So that's n connections, all right? So we don't want to kill. It needs to be a reasonable number that like the networking.
What do you
If
think
it's
the
a mobile
hardware
phone,
footprint
it-
sweet spot is for your system, the way you're targeting, what's the hardware footprint? Is it for something on a super powerful phone on a 5G connection? Is it something you're targeting for always on computer laptops or
So
machines? Or
the users, we want them to have just like basic hardware, right?
Mhm.
Like a phone should be fine. And I think this is really the originality with the system, is that we don't need light clients, because your own chain is relatively small, so you can just, if it's 20 block, you can have the 20 blocks on your mobile phone and create a 21st, and that's you don't need a light client. So that simplifies your work a lot. Right now we don't need to work on a light client, which is pretty cool. We don't need macro proofs at all. So if your block has a few transactions in it, you don't need to proof of inclusion for a particular transaction. Just look at the block. There are full transactions in it.
What's the average size of block you'd like to see? 20 blocks, I mean, how much
So-
gigs is that? For micro,
I think the blocks are going to be relatively small. I mean, you got once they are certified, you're gonna have like n signatures. If n is the number of two n over 3.
1,000 even. What's the size of a block? The range you think that'll come?
I mean, I'm not gonna commit to like particular size, but it's like if it's 20K or something like that, I'm gonna be happy. You know. I mean, so that what I'm trying to convey here is that we are not optimizing for large blocks, right? So because the TPS doesn't come from large blocks, it comes from many chains.
Exactly.
So that's
It's a distributed, real decentralized system. Yeah.
All right, cool. Well, thank you, Matthew, for giving us the presentation. I've learned so much. Thank you.